All right, this will be the key for factoring quadratics. I'm not going to do every problem here, but I'm going to do a fair amount of them, hopefully enough to get you started. In the first section, when we're finding each product, we're just foiling and combining like terms. So for number 1, I need to do my first terms. That's going to be 3v times 4v for a total of 12v squared. Outside becomes a negative 3v. Inside becomes a negative 16v, and my last terms gives me a 4. Once I combine my like terms, I get 12v squared minus 19v plus 4. Pretty straightforward. We've gone from factored form to standard form. Let's see, number 6 looks kind of tricky because of the negatives, so I'll do number 6 now. I'll do my first in my outside. Let's see, negative 2a times a is going to be negative 2a squared. Negative 2a times 1 is going to be minus 2a. And then I'll do my inside and my last. Negative 8 times a is negative 8a. Negative 8 times 1 is a negative 8. Combine our like terms, we get negative 2a squared minus 10a minus 8. All right, find all roots. Another word for roots is zeros or answers to the equation. So in order to do this, I need to find the values for x that would make this true. Because I've got two linear factors being multiplied, I'm going to use my zero product property to state that if either of those factors becomes equal to 0, then the whole thing is equal to 0. So I'm just going to set those individual factors equal to 0. I get x equals negative 5 and x equals 2. Make that negative 5. All right, over here we could do this one really fast. It's going to be x equals 5. That'd make that first factor 0. X equals negative 2 would make that second factor equal to 0. The zero product property states that if either of these becomes 0, then the whole thing is 0. So it's a true statement. Therefore, it's a solution to that equation. All right, factoring. Let's see. Let's grab number 12. Number 12 looks kind of tricky. I'm going to create this structure to start. Just x's with big blanks after them. This is simple factoring. My a value is 1. But what I'm going to want to do is fill in these values with numbers that multiply to be negative 8 but add to be 2. So maybe I'll write negative 8 over here. Let's see, numbers that multiply to be negative 8. Well, 1 and negative 8, but I add those together. And I get 7. That's not quite right. I'm looking for a 2. Maybe a 4 and a negative 2. That one does work if I add them together. So I want to do a plus 4 and a minus 2. We can double check this by foiling. Yeah, I didn't explain that one super well. Let me try again on another one to explain it even better. We'll do number 14. So it's simple factoring. My lead coefficient is 1. So I'll write out the two factors, no coefficients needed on n, and I'll leave a big blank. Now in these blanks, let me write a and b for the blanks. I know that a times b must be equal to 2. A times b is always that last value. I know that a plus b must be equal to negative 3. We always add to get this value. We always multiply to get this value here. Now I notice my b value is negative. Yet my last value is positive. The only way that this can work is if A and B are both negative, and that way they multiply to be a positive, but they add to be a negative. So let's try some things out. I've got 2. I can split that into a -2 and a -1. When I add those together, I do get the -3, so that works. N minus 2, N minus 1. Now I notice this is equal to 0 here. So I'm going to use my zero product property to solve the rest of it. N minus 2 equals 0, and N minus 1 equals 0. Add 2, N equals 2. Add 1, N equals 1. So 2 answers for number 14. Let's solve number 17 now. Now I notice that I've got this 7 over here. We want a 0. So how am I going to do that? Very simple. I'm going to subtract 7 from both sides. Now I've got r squared plus 7r plus 10. Create these structures. R, 0. Factors of 10, I think 5 and 2 will work because 5 plus 2 equals 7, but 5 times 2 equals 10. So r plus 5, r plus 2. Now I need to set those equal to 0 individually. So r plus 5 is equal to 0. That comes from that factor there. I'll subtract 5 from both sides. R equals -5. And the other linear factor is r plus 2 equals 0. I'll subtract 2 from both sides. R equals -2. All right, let's see. Do any of these require factoring by grouping? I think the last two do require factoring by grouping. Let me solve 19 real quick. Well, actually, 19 requires factoring by grouping too, so this will be a good one. The greatest common factor here is 2, so I'm going to divide everything by 2. I'll get 5x squared minus 7x plus 2 equals 0. Now I can't simplify that any further by just dividing away numbers because we've got 3 prime coefficients. So what I'm going to do is I'm going to split that -7 into a d and an e value. I know that d plus e must be equal to -7, but I also know that d times e equals 10. And that comes from the a and the c value here being multiplied. So that came from 5 times 2. The first and the last number there. So let's see, numbers that multiply to be 10 but add to be -7. That's going to be a -5 and a -2. All right, so that's my d and my e value. They do add up to be -7. So let me just keep writing here. Just going down, we'll just erase that real quick. Now that I've got the d and the e value, I know how to split -7 to make this work. So I'm going to make it 5x squared minus 5x minus 2x plus 2 equals 0. Now let's factor out the greatest common factor. This first one, we can pull out a 5x. We're left with an x minus 1. That's what we get when we pull out a 5x from those first two terms. Sorry, let me show my two groups real quick here with these blue parentheses. Those are my groups. And in that second group, my greatest common factor is a -2. Pull that out, I leave behind an x plus or x minus 1. Now I get 5x minus 2 is my first factor, times x minus 1, and this is still equal to 0. So let's keep going. We'll use the zero product property again, set each of these equal to 0, 5x minus 2 equals 0, and x minus 1 equals 0. I'm going to add 2 to both sides, 5x equals 2, divide by 5, divide by 5. X equals 0.4, and over here I'll just add 1 to both sides. X equals 1. So these are both valid solutions for that problem there. All right, let's do number 22. This will be our last problem. Number 22. Let's get it done. First thing I need to do is convert this into standard form by combining my like terms. So I'm going to subtract 1 from both sides. I'm going to subtract 8x from both sides and combine them with their like terms. So I get 2x squared plus 9x minus 56 equals 0. Now we're ready to go into factoring by grouping. I cannot divide away this 2 because 9 here is odd, so I don't want to be dealing with decimals. So I want to split 9 into 2 numbers. Those 2 numbers are going, we'll call them D and E. So D plus E needs to equal 9. D times E needs to equal negative 112. All right, so I'm looking for 2 numbers that equal negative 112, but I'm going to pick factors that are pretty close to each other because I know that their difference, the distance between these numbers, is only 9. Because I'm going to have to use a positive and a negative, but when I add them up, I'm going to get 9. So let's just see what are some factors of negative 112. Let's see, these numbers have to be close together, so I'm thinking maybe something in the 20-ish region, so maybe 112 divided by 14. That works out evenly to be 8, but 14 and 8 aren't quite the right distance apart. 112 divided by 16, maybe? That gives us 7. So 16 and 7, those are the negative. These 2 numbers multiply to be 112, but they add to be 9. So that's good. So let me split my equation here. It's going to be 2x squared plus 16x minus 7x minus 56 equals 0. Greatest common factor in my first group. Let me just group them together real quick. The greatest common factor in my first group is a 2x, leaving behind an x plus 8. And then there's a greatest common factor is a negative 7, leaving behind an x plus 8 in those 2 groups. Now I rearrange them. It becomes 2x minus 7 is my first linear factor, and x plus 8 is my next linear factor, still all equal to 0. All right, zero product property time. Set each of these equal to 0 and solve. Add 7, 2x equals 7, divide by 2, divide by 2. X equals 3.5. It's one answer, minus 8, minus 8. X equals negative 8. That is our next answer. Let's see how I did. Yeah, 7 halves and negative 8. Good. So that's how you can do some of these problems. Try the rest of them. And I will talk to you all later.